we've got John Heinrecy and Greg Fadler here to kick things off. And they're going to talk to you a little bit about some of the fun they had while they were employed by General Motors. And it's hard to believe. I mean, most of us would pay to have a job like these guys. It was great riding down here with John here and some of the adventures he had. And what a life they've had. So, you know, the number of national championships. Greg's had more cool jobs at cool places and getting roped into the best projects. And so I won't steal any of their thunder by getting into specifics. But welcome, Greg Fadler and John Heinrecy.
Greg and I are going to spend a little bit of time talking about something a little different than the normal Corvette stuff. Although we enjoy talking about that too, we thought you might be very interested in hearing some of the projects we worked on when we were in the performance division. Back when we got started in the performance division, we weren't sure what products we were going to be able to do very quickly and get going. We had to kind of grow up the business from marketing to get going on products. And one of the earliest ones, matter of fact, I think it was the first one, was taking the Redline Ion, the Saturn Ion, and putting a supercharger on, doing a supercharger package. And that started the Redline series for Saturn. And immediately after that, we followed up with Cobalt because it had the same powertrain as the Saturn, and a lot of the chassis was the same. So we did the Cobalt supercharged car. Once we started doing on that package, we decided we really needed to get promoting the cars that we were starting to work on. And so in SCCA, there's a grassroots racing. If you've got it, a lot of you are probably familiar with SCCA. There's a number of classes that are showroom stock or touring related, and they start off with T1 and go all the way down to SSC, and there's like 5 classes there: T1, T2, T3, SSB, and SSC. And these all are based off of very production cars. And so we took on doing some racing versions for each one of those classes. We'll get into that after a little bit. But one of the first promotional things we did was with the supercharged Cobalt. And the marketing guys wanted to do a show car for SEMA. That would be a Cobalt that would be all painted up, and they were modeling it after a Time Attack type of car. If you're familiar with Time Attack, it's a series at that time it was called, I think it was Import Tuner or Tuner Time Attack. And these were primarily Japanese cars that were being run, some European cars that were being run in these Time Attacks. If you're not familiar with that, it's basically a one lap on a racetrack at these various events. And they had a bunch of different classes. There'd be rear-wheel drive, four-wheel drive, front-wheel drive, there's street car, there's race car. And so they marketing wanted to build a show car and have an SEMA that would model after a Time Attack race car. And we convinced them to change the program to where we build a real car. Said, for what it takes to build a show car for this, we could build a real car and actually compete and try to win in Time Attack with the car. And so they agreed to do that, so we set about developing this Time Attack Cobalt. It was based off of supercharged Cobalt and running it into Time Attack. When we ran it in the full race front-wheel drive class, looking at what it would take to win that class, we decided several things you do when you build a race car. You make it as light as you can, try to get as much power as you can, make it handle real good, and those types of things. Well, we ended up with a Cobalt that was 2,250 pounds, with a lot of carbon fiber parts on it and lightweight things as much as we could do. We had a supercharged engine. We decided on using nitrous on it instead of just trying to build a full race engine. We used the base engine and had it tuned with different pulley size running supercharger, and we added a nitrous system that was done by Martin Technologies in South Lyon. If you're familiar with Martin, he's a drag racer and does a lot of nitrous setups for the drag cars. So I think we had a 120 horsepower nitrous shot that we put on the car at the same time. We tried various things like ice baths for the intercooler and that kind of thing, but it added too much mass to the car. So the bottom line is that we ended up taking this car and running it or having it SEMA in the show, and then we ran it at the last event of the year at Buttonwillow. SEMA went to California and ran this car in the import tuner. It wasn't called import tuner, but it was like a tuner Time Attack is what it was called, something like that. But it got a lot of notoriety, good magazine articles, and it was on a TV show. We're going to show you the video here, and not spend a whole lot of time talking about the program, but it was pretty cool, and the video I think will speak for itself. Then we're going to talk about the racing programs that we also undertook to promote our GM vehicles in grassroots racing.
Division built Chevy Cobalt. Under the multicolor tearaway paint is a purpose-built time attack car that was putting the scare into a lot of big horsepower cars at the track.
The Cobalt SS Supercharged is new for 2005, and we decided to enter the time attack with Prime Media in the unlimited front-wheel drive class. This car started as a Grand Am Cup race car, and then we made some modifications to it to make it more suitable for the time attack and make it faster.
The stock Cobalt SS Supercharged is very track capable. We actually run a 24-hour track test on every performance car we put out to make sure the designs and everything are right. The Cobalt Supercharged was no different than that, and that's with stock tires, brakes, everything.
Our philosophy on doing this car was that we weren't going to overpower any particular part of the car, but it was going to be a very balanced car.
We have a Gen 5 hybrid supercharger on this, puts a little bit more efficiency. Base engine makes 264 horsepower. We started out running an 80 horsepower shot of nitrous today, went up to 120 horsepower shot of nitrous. So we were basically making 364. Horsepower is not just the name of the game. It's power to weight ratio. It's developing a total integrated package with suspension and everything working good to get around a track, and that's what's going to win things.
For me, driving it, it was extremely easy to drive, because the guys developed it to make it easy to drive so we could use every bit of the car to the 100% limit. We're running a stock radiator in the car. It has a better Griffin aftercooler in it for intercooling the supercharger. And then the performance parts kits, which are different injectors, a smaller pulley on the supercharger to spin it up faster, and a calibration that our engineers internally worked on a calibration to make as much power as we could. The brakes are production except for the front rotor. It's got a two-piece layer front rotor on it. So a lot of really stock components on it. I'm really proud of the guys on the team who did this. 99% of the parts that are on this car are bolt-on parts.
Most people who built their car from just bolt-ons would be happy to get invited to the time attack, but GM wasn't going to be satisfied just being there. They wanted to win the whole event.
For us and our whole team, a lot of the challenge was to make a front-wheel drive car that would handle so good.
And some of the Skylines were 650 horsepower all-wheel drive cars that we beat with a 364 horsepower car. So it's obviously not about power, it's about having a total package that performs as good as you possibly could. We're going to get started in the rest of the presentation here. I mentioned to you some of the classes in SCCA. They're listed up here: T1, T2, T3. Now, T1 typically is where the C5 and C6 Corvettes, and next year I expect to probably see a few C7s out running. T2, now this was back in 2007 with the Solstice GXP, the Cadillac CTSV. There were a couple of those running, and also Pontiac PTO from GM. But obviously, looking at the competition, it's Mustangs, Porsches, Nissans, BMWs. In T3, it was the Cobalt Supercharged and the Ion from GM, and running against Mazda RX-8s, Scion, Mustang GT, and SSV was the Solstice non-turbocharged. And then SSC, which is the slowest one, was the Cobalt SS non-turbo and non-supercharged car. What I wanted to do, and what my stretch goal was in 2007, was I wanted to win all 5 classes for GM. So a GM car would win all 5 of these classes. That was really what was in my mind to do, and we set about having packages that were available to people to buy for their cars, or buy the car that way, that would make it capable. And Greg can spend quite a bit of time talking about the technical aspects of making that happen. But the bottom line is, we went to the runoffs in 2007 and won every single class. As far as I was concerned, we won them all. What happened was, we won all of them except for the T3 class. I was driving a Cobalt SS Supercharged in that class, and I was leading the class, and I got disqualified for too much noise. for exceeding the sound limits.
You were 13 seconds in the lead.
Yeah, 13 seconds in the lead, and I got disqualified for too much noise. So that kept us from winning all 5 classes, but we had a lot of support from management to do this kind of thing. We were getting into all the performance cars that we were doing in the performance division, and this was part of our strategy to support the brand and support, get people out there wanting to buy the car, basically.
I wanted to take a couple of minutes and maybe give you a little bit of John's background. John's a mechanical engineer from South Dakota School of Mines, and John joined GM in the late 60s and kind of worked his way around and up through the organization, and was assistant chief engineer of the Corvette, was the chief engineer of the Camaro Firebird, and also the director of GM's performance division. And John likes to drive, and in terms of raw talent, he's probably one of the best drivers I've ever encountered in my career. And we used to use him kind of as the reference standard for other drivers. We'd use him as the reference standard for how to kind of set cars up and figure out whether or not we had it nailed based on how well John could drive it. So he's pretty humble about who he is and what he's done in his career, but it's truly amazing what John has been able to accomplish. If you look back, at some of the really iconic cars out of GM's performance division, it's really a testament to John and his vision of what production cars can be if you just apply a little bit of engineering to them. So with that, I'm going to kind of roll into a discussion about race car engineering. And I want to make clear that just about everything I'm going to tell you today, John taught me. One of the greatest honors of my career, having met John as a young Corvette engineer, was in 2004. John was walking through the proving grounds passing out candy at Christmas time. And he said, "Greg, would you like a piece of candy?" And I said, "Sure, John." And he said, "Oh, by the way, we're forming a race engineering group and I'd like you to manage it." And I thought, wow, okay. I'll be glad to do that. And I'm an aerospace engineer for some of you that were here last year, and that was one of the reasons John was interested in having me come aboard. Is there's 2 things you got to do well in racing: aerodynamics and also chassis. And John, of course, is a chassis expert, and I'm an aero expert, and I was pleased to be a part of the team. So we've got a number of tools. They were listed up above. The first one is lap simulation. We actually can do a computer simulation of a vehicle on a racetrack. We'd have John drive the track, we'd get a data file, and then we could modify that data file with different tires, different engine, different aero, different weight and balance. It's a way for us to do a virtual simulation of a car. And we used to actually use this to figure out, will the car work? Can we make a car that will win a national championship? And our goal was to always win a national championship. We test tires on a tire machine, so we'd send our race tires out and we'd test tires. Next slide. This is actually at CalSpan. We'd use data loggers to keep track of our vehicles on the track. Again, a relatively inexpensive device, about $1,000. Next slide. We'd use a 7-post machine. This is actually Highline Racing stuff. We actually built one of these in GM's durability lab. And the actuators are the same as what you'd use to do a chassis durability test, but you think about a vehicle as it goes down the road, you're putting loads into the tires. Well, we call it a 7-post rig because you have the 4 tires, but there's also 3 other hydraulic rams pulling on the body. So we can simulate the aero loads and the track conditions on the vehicle as it kind of moves around. And we would use these to actually tune shock absorbers. So this is the same technology that IndyCar, Formula One, NASCAR, they all use these kind of chassis shaker machines to tune shock absorbers and suspensions. We use these on every one of our packages. This is a picture of a Corvette road race car in GM's wind tunnel, and I just threw this in here just to kind of give you a feel that, yeah, we actually do wind tunnel testing too, and that's kind of my thing. Next slide, John. And so let's talk about how we start, right? When we wanted to do a race car, the first thing we would do is read the rules and make a plan. So just kind of flip through these, John. The first step, obviously read the rules. Next. Your strategy and plan must take full advantage of the rules or the lack of them, right? If you're gonna, I used to joke, first show me the rules and then we'll tell you how we're gonna race. we would figure out how to make the rules and the class work to our advantage. Next slide. Different is sometimes better in racing. Never be constrained by the status quo. Racers tend to be a lot like sheep in that they follow the guy in front of them, right? And it's not always the right thing to do. Next slide. Never show your best effort early in the season. We learned this the hard way, and I won't tell that story today, but John's going to laugh. When the sanctioning body's trying to slow you down, you need to slow down. And the answer is when the sanctioning body tries to slow you down and you speed up, it makes them really mad. So let the sanctioning body win a few debates. Tech inspectors will always find an obvious infraction. And so sometimes you want them to find an obvious infraction. They feel really good when they find an obvious infraction. They spend a lot of time on an obvious infraction. Know the sanctioning body's rulemaking schedule. This is something John taught me. So every sanctioning body has a committee, and the committee meets, and the committee decides on new rules and changes and penalties and all that good stuff. If you know what that schedule is, and when the last meeting is before your national championship, that's a helpful piece of information to have. So, next slide. If it isn't expressly forbidden, it must be okay. Smoky unit. And so, we study history a little bit, and certainly Smoky is rich with history. What is the racing dilemma for big companies? I threw this in, and I think I told John this back in the day. But when we showed up at the track as General Motors, and we win, what are we? We're jerks. Yeah, big nasty company, right? When we show up at the track as General Motors and we lose, what are we? We're stupid, right? So that's a dilemma, right? What do you do as a big company like General Motors when you want to get into this and you show up in grassroots racing and you win? How do you avoid being the bad person? And the answer is you teach. You teach your competitors, you teach your customers how to win with your product. Our mission statement was to make GM the compelling choice for grassroots racers. And you make them the compelling choice by teaching and by offering products that win. And so you're foolish if you want to run in those 5 classes that John was talking about and not run GM products in that era because we were winning. Scope utilized the full resources inside GM and win grassroots. The Solstice Z0K race car plan considerations, it had to be offered as a regular production made in the plant. We had a young, inexperienced team of engineers, so I personally led the first project, which was the Solstice Z0K. We had federal and state laws to comply with. We had timing issues. We had investment, piece cost, option price issues. We had mass engine power, aerodynamics, vehicle dynamics, lap times. We had manufacturing issues. We had labor time, low volume, build planning. We had homologation issues, vehicles and parts. We had marketing issues that we had to work through. So those are just kind of an overview of the challenges. When your primary competitor, Mazda Miata, weighs less and has more horsepower, how do you win a championship? Well, that's one way, and yes, but the answer is you make the car handle. And so when you have to design, release, develop, validate, certify, qualify, and compete in less than a year, when your race team of young engineers has never developed a race car before, when it's against the rules for the factory to field a car and compete, work smart and fast, never give up, and be humble. So we basically overcame every one of these challenges, and we did it with that car, again, in less than a year. What's in the name? The Z0K Club Sport. For Chevrolet, Z typically denotes special high performance. Pontiac uses WS6 or something. K is for Kappa. So originally we called the Z0K Club Spec, which was the same term Mazda used for their high performance variant. Pontiac marketing wanted a name that denoted a higher level of performance, and so we used than what Mazda used. We used Club Sport, which was Porsche's. I literally got a call from Pontiac marketing. They said, we can't call it the Club Spec. We don't want to copy Mazda. And I said, well, what do you want to call it? And they said, we don't know. That's why we're asking you. You got 5 minutes to decide. And so I reached into my bag of tricks and said, well, let's call it the Club Sport. And the marketing guy goes, oh, I love that. That's great. I didn't have the heart to tell him that's what Porsche used. So run an analysis, develop a rough set of performance parameters based on an assessment of the vehicle, and use the lap simulation I mentioned. Use the championship track as the venue. If the simulation suggests a competitive advantage, then proceed with hardware. If it doesn't, adjust the plan and analysis until you develop a viable set of parameters. Convert the performance parameters from vehicle level requirements, subsystem, all the way down to component, and evaluate viability for each part of the plan and execute the plan. Now, I know this seems complicated, but we were doing this in a very, very rapid turnaround environment. I mean, at General Motors, to develop two vehicles, the normally aspirated and the turbocharged car, each in less than a year, was amazing to be able to get that done with full durability and whatnot. And the interesting part of the T2 car was we assumed we would get a kit from SCCA. Because we have one on T1 for Corvette, we just assumed we could design and build a chassis kit and we would offer it through service parts. People would buy the car, the turbo car, and they would put the kit on and we would be fine. Well, it didn't quite work out that way because what I'm going to tell you about in a little bit. And we had to actually release that kit as a regular production option to be made in the plant. That presented a challenge. So here's the lap simulation, back to kind of the base car. The lap simulation told us we had a 2-second a lap advantage over the Mazda Miata. That's huge in road racing. A typical showroom stock B race, the national championship is decided by a few tenths of a second. We had 2 seconds per lap advantage over our competitors. So we knew from this analysis we had a winner. And what's the most important attribute of a road race car? And the answer is handling. That's how we were able to overcome the mass disadvantage and also the horsepower disadvantage. Road racing cars spend most of their time cornering, so improving handling is the best way to improve lap times. How do you make a car handle better? Any
Suspension.
yeah? All this stuff, right? Tires, ride height, suspension geometry, springs, bushings, bumpers, sway bars, shocks, structure. And the answer in this particular case, the key enabler was lower the ride height. And so what we did for the Z0K is we had to quickly change the springs. We kept the same rate as the turbo car for the next year, but we lowered the ride height by 14 millimeters. And you say, well, why 14 millimeters? That's the exact amount that you get if you put a second spring seat in a purpose-built coilover suspension. If you put 2 lower spring seats in, you pop one of those spring seats out, you get 14 millimeters of ride height adjustment down. 14 millimeters was important because the car was designed to have 18 millimeters of variation in the assembly plant. We had no optional content on this vehicle. We could lower the car in minutes in a person's driveway by removing that extra lower spring seat and get 14 millimeters of ride height adjustment. And that 14 millimeter reduction in center of gravity gave us perfect tire geometry. It gave us much better handling, allowed us to run lower profile race tires. It created the entire package with one simple change. And that simple change is what enabled that 2 seconds a lap improvement. So something that initially we never even thought of turned out to be the key enabler to make the car champion. Tires. It's mostly about the tires. Run the biggest tires that will fit within the rules. Frequently this requires custom wheels. Some classes, the showroom stock classes, you have to run stock wheels. Service bulletins for safety. We actually wrote a service bulletin that said, for optimum tire wear and safety in high performance events, lower your suspension 14 millimeters and set your camber to -2 degrees. That just happens to be the perfect setup for road racing and perfect tire wear. Even tire temperatures, even tire wear meant we maximized tire life by doing that as well. When we maximized tire life, we figured out that we could run A-compound tires. Any racers out there? We figured out how to get A-compound tires, autocross compound tires, to last for an entire 20-lap road race. So we actually designed the suspension to get the tire wear so perfect, the A compounds were a key enabler. So not only did we have better handling, but we also had better tires, we had better grip. The A compound tires were a game changer and a key enabler to winning that championship. Lowering the center of gravity is the best way to improve a vehicle's handling. There are legal challenges, rules, ground clearance, tire clearance. So the service bulletin was what enabled that. I have a story to tell. And again, I told you guys I'm a rocket scientist. But I had been in the Corvette program for about 9 years. And while there, I had met a lot of really famous people. Obviously, John's one of them. I also met Dick Dahlstrand, and I got to know Dick pretty well. Dick Dahlstrand told me one time, he said, run the stiffest springs you can get. And John Heinrecy told me when I went to work for him, run the softest springs. And I'm thinking, I got two famous racers telling me to do two completely different things. And this kept me up at night, actually. Why would these two great drivers tell me the complete opposite thing? And I started to realize Dick Dahlstrand had never driven a car with good suspension geometry. John Heinrecy's never driven a car with bad suspension geometry. And so the difference between Dick Dahlstrand's stiff springs and John Heinrecy's soft springs, Dick Dahlstrand doesn't want the suspension to articulate because bad things happen with bad geometry, right? John Heinrecy wants soft springs because now the tire can follow the road and you get maximum tire contact with the pavement and maximum adhesion. So the fast setup is actually softer springs and bigger bars. Dahlstrand wanted stiff springs and thin bars, but that's what was required to work with the old suspension geometry that didn't really work right. So kind of a bit of a segue here, but for me this was an important lesson because as a amateur tuner years ago, I used to think about, well, should I run stiff springs or should I run soft springs? And John again schooled me on this. How do you maximize handling? Maximum tire adhesion. More negative camber was required, so we wrote that service bulletin, we lowered the CG, we added the negative camber. So let's move into the turbo version of this car. In here, I guess I should tell the story of the Z0K SSV at the runoffs in 2006. So again, this is the first project of the department. It's kind of my first project working for John in this capacity. The car got on the track and we had a guy named Don Knowles driving it for us. And when we got to the venue and started the race, it was in debate until the first corner. And at that point, Knowles pulled into the lead. And John was talking to him on the radio. And after the first lap, Don, you're 2 seconds in the lead. And about halfway through the race, John was, Don, you're 10 seconds in the lead. And then about 3/4 of the way through the race, John's getting a little more animated. Don, you're 16 seconds in the lead. And by the end of the race, Don, you're 26 seconds in the lead. Now, some of you are probably wondering why John was worried about Don winning the race by 26 seconds. He's getting more and more animated. Well, what does the sanctioning body do when you win the national championship by 26 seconds? Change the rules. They gave us a 200-pound mass penalty. So what do you think we did with it?
You rode along.
Yeah. Right. The Solstice has a lower closeout panel for the structural tunnel. So I had the engineers replace that sheet metal with a piece of 1/4-inch plate steel. Didn't quite get us to 200 pounds. So I said, weigh the car on the balance, and tell me what it weighs. So they weighed it, and I said, okay, take whatever weight is left and put it in the rear bumper with a slug of lead. So they did that, and my engineers come back to me and say, Greg, guess what? I said, okay. They said, well, we lowered the car by 1/4 inch, and we now have perfect 50-50 weight distribution. Thank you, SCCA, for making us just a little bit faster.
Not only lowered the car, but it actually lowered the CT too with the
Yes.
gas down low.
Yeah, because the plate was below the center of gravity, any weight you add lowers the CG. So anyway, back to parts. We had to have a plan for every part. The base car had new front springs. The turbo car had just these 7 springs. We added new bars and springs for the turbo car just because we could. And by the way, when we went to the turbo car, we could run bigger tires. So as soon as you put bigger tires on the car, you frankly need to step the springs and things up a little bit because you've just increased the loads on the vehicle. So by going to the bigger tires, we drove new spring rates and we drove bigger bars. Again, softest springs that would work with the car. So again, I told you about soft springs versus stiff springs. We developed everything on the national championship track. We knew where the national championship was going to be, so we optimized there. Why optimize anywhere else? The safety bulletin, John did a great job kind of explaining that. Bushings and bumpers are greatly affect the vehicle's handling capabilities at the limit, so we put firmer bushings in, and generally those are better for racing. Z0K had the firmest bushings that were available. Jounce and rebound bumpers were carried over from the turbo car. Stiffer bars were needed. The front diameter was unchanged from the base Z0K to the GXP, and then the GXP Z0K got bigger bars, again as I explained. We could actually run in the T2 class Penske shocks, so we used a company to help us develop the Penske shocks for the turbo car, and we did that obviously on the 7-post rig I showed you earlier. We also added a structural reinforcement to the back end of the Solstice, doing the Z0K, and Dave Tolinius, one of our development engineers, figured out that the rear suspension was actually complying under the race loads of the tires, and figured out that if we added this part, it would greatly straighten things out. We commissioned full computational fluid dynamics analysis of the car, and we figured out that the rear spoiler, John and I actually had an interesting discussion on this, and I said, John, you know, we can't make the spoiler on the Z0K turbo standard because of bumper regulations. And he said, well, I'll bet you, Fadler, we get a 1/10 of a second, but not much more than that. And I said, well, we're going to run the lap sim. So we got the aerodynamic data, we put it in the lap simulation. We actually got a 1/10 of a second for drag improvement, as John had predicted, but we got 2/10 of a second for improvement in downforce. So that part actually helped us in lift and downforce. Carbon fiber roof. Now this is another interesting story. This particular class requires a hardtop. Mazda Miata's hardtop weighs about 100 pounds. The Solstice needed one as well. We used the show car tool to make a carbon fiber roof panel, and it only weighed 8 pounds as opposed to the 100 pounds. So that was another one that where tell us the rules, and then we'll tell you how we're going to race. The Solstice Autocross team kind of jammed us up a little bit. We built the first 6 GXP Z0K cars, and we sent them to Milford. When we built the cars in the plant, we only had parts to make one. This story hasn't really been told, but I'll tell you guys. So we shipped the cars to the proving grounds, and then we retrofitted the parts later to turn them into actual cars. The Solstice Autocross team had a set of those early parts. They went to a national event and got protested. When they got protested, SCCA gave us 30 days to fill the dealer pipeline with the parts, or the Z0K turbo car would be disqualified for 2007 competition. We checked, and only 2 orders were placed. 2 customers bought the parts. One was one of our Solstice racers, the other was a Mitsubishi racer. We filled both orders right on time. On literally the last day, both sets of parts arrived. The rest of the story is a little bit interesting. GM filled both parts order twice, and they posted that as well. And GM Service Parts was running behind getting these orders filled. We were pretty certain that GM Service Parts would fail at getting the parts to the dealers on time, and we would be disqualified. But we had parts by this time in the engineering shop. So we literally took the parts and packaged them up and shipped them from engineering to the dealership, and the parts arrived on time. The racers dutifully reported that GM filled the order on time, they bought them, and then a week later, service parts filled the order, and they arrived late, but they arrived, and both parties said that, well, silly GM, they filled the order twice. And so the answer was, yes, we filled it twice, but I have a thing I go through on time, I'm gonna skip it. Time is the ultimate competitive advantage. If you can run a lap faster than your competitor, you're gonna win. But if you can decide faster, you're gonna win too. We built a couple of show cars. This show car actually got seen at the Indianapolis Raceway and photographed, and it created a bit of a buzz. There's an interesting story here. We did a calibration for the turbo cars and took them from 235 to 295. We were running at the National Championship track in October in Topeka, Kansas. It was cold. We swapped every racer's engine control module out with a new calibration. And we said, we need this calibration back by the end of the weekend. And they said, well, we want to keep the high performance cal. And we said, you really can't. And we need it back. It's a special cal. What we didn't tell them is if they would have run that cal on an 80-degree day, their engine would have blown up. So we were literally right at the ragged edge, getting 295 horsepower out of a 2-liter motor. The Z0K was considerably faster in race trim than the new Camaro SS and probably the 1LE. The new ZL1 Camaro, I think, is actually faster. So we had a dilemma in-house as well about how do we want to make sure we position the Solstice compared to the other products that were coming in the pipeline. GM's partner was Joe Aquilani from Phoenix Racing. And John and Joe have a long relationship. iRacing also sponsored the cars. And again, for project management summary, develop a plan, analyze the plan, execute the plan, improve, adapt, overcome. I love that in the U.S. Marines. Validate the plan, reap the rewards of winning. In 2006, we qualified first and second, and placed first with a 26-second advantage. A special edition was created in honor of that event, and the Z0K Turbo qualified 1 through 4 in 07, placed 1 through 3rd. Fourth place car was well behind the first 3. The Z0K program was an overall overwhelming success. Sadly, of course, it wasn't enough to save the Pontiac brand, and they ceased operations in October 2010. By leveraging the resources inside GM, we were able to take GM's best technology and apply it to grassroots racing. The same technology used in Indy, Formula One, etc. And by integrating the total package for racers, we were able to eliminate the tuning process for new cars. We made GM the compelling choice for grassroots racers. The Z0K's mission and goal were accomplished, and the weight penalty on the car, I told you about that. This is Don Knowles just after he won the national championship in 07 in the turbo car. We actually wrote a book. I mentioned Teach. We wrote a book on how to convert a Solstice into a race car. It's still available. We taught our customers how to win. A couple of recommended books for reading, and then there's the part number for the Solstice. There's a couple of Solstice videos. Now, I promised to tell you a Corvette story. This is an actual quote. Greg, please build me a Z06 race car, but don't spend any money. We were heading, GM was having some economic troubles in 2006, and John wanted a Z06 race car. So, the first thing I did was, and I worked on the Corvette program for 9 years. I remember I told you that story. So, I called the Bowling Green paint superintendent, who I knew as a former Corvette body engineer, said, "Hey, you got any Z06 paint bucks?" He goes, "Yeah, I got one. I was just about to scrap it." I said, "Don't scrap it. I'm, ship it to Milford Proving Grounds." He goes, "Okay, well, a paint buck is a new aluminum frame with a body on it and about 30 coats of paint." Okay? So I got now a brand new frame with the body on it. I then asked the paint superintendent, what's the #1 body panel scrapped, or color scrapped for paint defects? And the answer was silver. So I said, get me a complete set of body panels painted silver and ship them to the proving grounds. Scrapped. Stuff that GM's going to throw away. What's the wheel option for Z06? Because there were 3, right? There was aluminum, there was chrome, and there was black. Which one has the most cosmetic defects? And the answer was the argent one that was painted, because the other ones are polished and whatnot. I said, send me a set of those. We did a new single-piece brake backing plate instead of the 6 pads. I called Dave Wickman, the head of vehicle development, and said, you got any old durability vehicles? He goes, yeah, I got one. I was about to scrap it. I said, don't. Send it across the hall. So it was in the same building as our race shop. We got a rebuild LS7 from GM Powertrain because there was a launch issue with that engine, had piston slap on startup. We rebuilt the transmission and transaxle at the proving grounds. We actually had to invent something here. An aluminum frame on a car can't have a steel roll cage welded to it. Or can it?
We used to think that.
We actually had I've got a patent. You can actually weld aluminum and steel together. There's one process that will allow you to do that. It's called spin welding. You take 2 pieces of material, you spin them, and you jam them together, and aluminum and steel will spin weld together. We created a slug, half aluminum, half steel, that we sold through service parts that would allow you to weld the aluminum to the frame of the Z06 Corvette and then weld a steel roll cage to the stub end. Pratt & Miller did the roll cage. We spent a little bit of money there. We bought race wheels and tires. We got a T1 suspension kit out of service parts, and we did a race seat, a fire suppression system with a window in. We only ran the car once at VIR, and all John would say was it was fast. He didn't want us to publish any of the information on the car. To my knowledge, it never really got out how fast the car was, but it was fast. And it turned out we didn't do a ton with the car simply because the cost for a grassroots racer to buy a Z06 and go racing was pretty extreme. The interesting part of the story was I look back on this and kind of, as an enthusiast, this is what we would do in our own shops, right? We would never throw away a paint bucket. We would never throw away a durability car. We would never throw away, paint panels that are blemished. We would turn them into race cars. So that's kind of it. Anybody have any questions? I hit you with a ton of information really fast.
Thanks so much. I'm really, you guys are back out of the park, so what a great way for us.